Welcome back. We want to continue our discussion on Python. And as part of that discussion, we want to look at how do we actually create a class within Python and how do we use these classes to create objects. We're going to be using our C++ class as the basis from which we are working. And remember that the whole concept of a class is that we are creating a blueprint for an object. And in creating this blueprint, we are defining what the properties are. So like int, radius, and float area, those are going to be the properties. And in addition to having properties, we also want to have operations, which are going to be the functions that allows the class to work properly. And remember, we are going to call these functions methods, just to show that these are functions that are associated with a class. So let's go over to our Python compiler. And we are going to start fleshing out the class. Now, first thing that we need to type is the class keyword, just as in C++. And then we're going to give the name of the class. In this case, the name of the class is ball. And then we put a colon. So that is pretty much synonymous to line 11 in C++. The next thing that we want to now do is to define the properties. And we're going to be defining the properties one by one and testing them so that as we go along, we're able to see that things are working fine, instead of writing one big program and testing at the end and then realizing that nothing works. Now, in order to create the properties inside of Python, we need to do this through a method. And the name of this method over in Python is called the init method. So it's going to be the def keyword because we're defining a method or a function. And the function is a special function, so it's going to be underscore underscore. It's called init, then underscore underscore. And all of the operations, the methods in Python, are going to have one parameter at first called self. So this parameter is necessary, and this parameter allows the class to refer to itself. And just to give an analogy, whenever we're talking about ourselves, we use the words me or we use the word I. So whenever I say I am going somewhere or I am running, then it means that I'm talking about myself. In a similar manner, this keyword self allows the class to refer to itself. Now the functions have a colon at the end. And please bear in mind that the whole concept of indentation is important. Note, if I had line 5 like this, lined up with the class keyword, then it would not indicate that the init function is a part of the ball function, is a part of the ball class. So by indenting it, it now tells us that this method is contained within the ball class. Similarly, when we now need to define the operations or the commands inside the init function, we now need to indent to show that the statements that follow all belong to the init method. Now, how do we actually create properties? We create properties by attaching them to the self keyword. So for example, self.radius, and let's say that the radius is equal to 15. So as the programmer, we are hard coding the value. And now once we have done that, the next thing that we want to do is to actually write the show details operation. Because remember, the show details operation is what actually displays the information onto the screen. So I'm going to create another function. So it's tab, def keyword, name of the method, which is show details, parentheses, and all of the methods are going to take in the self keyword as the first parameter. So we put self there, and then we simply say print, and let us do a formatted print. And what we're going to print is radius is followed by the radius. Now, because the radius is a variable, it has to be inside of this begin and end. And in order to get access to the radius, we still have to make use of the self keyword. Next thing that we want to do is to now create an object. And to do that, we need a main program. So remember, to do the main program, it's underscore underscore name underscore underscore equal equal. Then we have our double quotes. And inside the double quotes, we have underscore underscore main underscore underscore. So we now have the main. And next thing that we want to do is to create an object. We create an object by having an object name. In this case, I'm calling the object B. And we are going to assign B to the name of the class. So the name of the class in this case is ball. And then we're going to look at the init function. And we're going to ask ourselves if the init function takes in any parameters apart from self. Because there's no other parameter apart from self, then it means that the parameter list in the main program is going to be empty. And then we can now make use of the ball object B by saying b.show details. Now, show details is an operation, so we need the parentheses. And once again, this operation takes in only the self parameter. So therefore, in the main program, it means that the parameter list is going to be empty. And we're now going to execute this and see if it actually works. And if we look at the output screen, we're seeing that radius is 15, which means that the show details operation is indeed working, because that's where the radius is, followed by the content in the radius property is taken from. And line 15 also tells us that the initialization method is working fine, because that's where we assign the value 15 to the radius. Now, just to demonstrate that it actually works, we can make a few tests. So we can change 15, for example, to 32, re-execute, and it should now say radius is 32. And we are seeing that inside of our output, which demonstrates that things are working as we anticipate. So we have created our first class in Python. One of the things that I want you to realize is that the concept is pretty much simple once you understand the syntax. And if we compare it with the C++ solution that we had done before, we can see that there are commonalities. We use the class keyword. We need to give our class a name. There has to be some way for us to create our properties. And there has to be some way for us to create our operations. We have demonstrated all of that over here in Python. So let's continue. One of the challenges with this implementation is that the radius is set by the programmer. We want to change it so that the radius is actually set by the user. And we're going to do that by introducing another parameter. I'm going to call the parameter R, short for radius. And then we're going to say that the radius that is attached to the class, attached to self, is going to be equal to R. And what this now means is that in order to set the radius in the main program, we now have to pass in a value for R. And the question becomes, where is that value for R going to be passed or is going to be placed? And it's going to be placed inside the ball method. Remember, we said that we're not going to put self because that is going to stay there by default and it is understood. So it is anything apart from self that we are now going to introduce. It therefore means that if we want to set the radius to 16, then we simply put 16 there. And whenever you say the name of the class, I want you to associate the init command with the class name. So whenever we use the class name, it means that we are executing the init command. And we are executing this init command with the value 16. The value 16 is going to be in R because the value 16 actually represents the parameter that follows the default parameter, which is the self parameter. Let's now try this out, see if it works. And we are seeing here that it says the radius is 16, so it works as we anticipate. So what we can now do is to flesh out the properties a bit more. We know that we also need an area. So you should now note that we want to attach the area to the self keyword. So it's going to be self.area is assigned some value. And the value that is going to be assigned is going to be a value that we want to accept from the user. So because we want to accept that from the user, it means that we're going to go to the init operation, and we're going to add another property or parameter called A. We then take that parameter and we assign it to the area. Now, how does this change the main program? Well, in this case, we have to look at the init command and ask ourselves how many parameters it needs. It needs 2. If we look at the main program where we're creating the object, and we look at the operation that represents the init command, we realize that it's taking in one thing. We need it to take in 2. So let's say it's 100. And then we also would need to update the show details operation so that we can now show the area. So we now say area is, and to get access to the area, it's going to be self.area. And we're now going to execute. And we should now be seeing radius is, area is. So there we go. Radius is 16 and the area is 100. So we have now added 2 properties to the ball class. And we have made use of the show details command in terms of printing the content of these properties. Also note that we have set it up in a way so that the user can determine what these values are. Which takes us to the next point. In line 17, the values which are being entered are still being determined by the programmer. We don't want the user to be able to enter those values. And we can do that by making use of the input command that we would have seen before. So let us create some variables. So let's create rad for radius. And that's going to be equal to input. And input, we're going to say enter radius. colon, and a space. And remember, whatever value is obtained by the user here is going to be stored inside the variable rad or RAD. Now, bearing in mind that we want an integer value, then it means that we need to put the int command around this input command. Notice we are putting the parentheses for the int around the entire input command. And once we have done that, then it means that we now need to replace that first parameter with RAD. We're now going to do something similar for the area. So let's call that AR is equal to, once again, we're using the input command. This time it's going to be enter area, colon, and a space. And the same consideration in terms of converting one integer is also going to be applicable. So it's going to be int. We open the bracket, and then we're going to close the bracket at the end. Now let's try this and see how this works. But first of all, we need to change the 100 to AR, and we're now going to execute. So as we can see here, it's asking us for a radius value. So let's enter 21. And it's asking us for an area value. So let's enter 400. Hit the enter key. And the message is now telling us that the radius is indeed 21. That's what we have stored based on the user input. And the area is now 400. That's what we have stored based on the user input. So we have now created an interactive main program that makes use of the ball class. Now there are a few more things which we need to do. And let us deal with the color, for example. And I'm not going to do all of this. I'm just showing you the process so that you can actually do this for yourself. So I'm going to now introduce another variable C. And we need to now create that color property. So remember, we attach it to the self. So it's self.color is assigned C. We're now going to need to go to show details and display that. So let's copy the print statement and let's change what needs to be changed. So its color is, and it's going to be self.color. We would now come to the main program. But let me do this from scratch. So let's call the variable call. And this time we have the input and we say enter color, colon and a space. Now remember, whenever we use the input command, the value that it stores is going to be a string by default. That's why we have to convert both the radius and the area into its numerical equivalent. But in this case, seeing that color is a string, then we can leave it as is. And then what we can do is now take in that attribute or that property or that parameter into the ball initialization operation. And we can execute enter radius 5, enter area 10, enter color red. And we are getting now the output. Radius is 5, area is 10, color is red. So everything is working super smooth so far. Which takes us to just one more thing now to round out this. And that is the section here that has to do with whether or not the ball is inflated or not. So let's try and simulate that over here in this section. Now, in terms of determining if the ball is inflated or not, then there is this property called has air. So let's call it HA. And self dot has air is equal to HA. Now what we had over here is if it is true, then it's inflated. If it's not true, then it is not inflated. So what we're going to do here in the main program is we're going to take in the value true. Now notice how I've typed true. It's a capital T. And notice that it changes color to indicate that it's a keyword. So we're taking in this value true, and we are now assigning it to HA. And from HA, it now goes into the has air property. Now we need to go to the show details operation, and we need to code up that section so that we can display whether or not it is inflated or not. So we need this if statement. So if has air is equal to true, remember we'll put the colon and then we indent under that. Then we are going to print ball is inflated. Then we're now going to have our else. We're going to indent and then we'll print ball is not inflated. Let me emphasize not. So we are checking to see whether or not the ball has air. And if it has air, we print that the ball is inflated. Otherwise, we print that the ball is not inflated. In this case, we have determined that the ball is going to be inflated. So let's try that and see what happens. Okay, for the else, we need the colon. Let's re-execute. So we are going to enter radius. Radius is 10. Enter area. Let's say that the area is 200. Color. Let's say that the color is black. And let's have a look at this output. Also, has here has not been defined because I forgot to put on the self before it. These are some of the things that you have to look out for. So it is self dot has air. So we can re-execute. So that's 10, that's 200. We had said black. And now just having a look at the output. So the radius is 10, the area is 200, the color is black, and the ball is inflated. And the ball should be inflated because we had set has air to be true. We can also set has air to be false, but before I do that, I'm going to do a print here. But let me put it inside of the show details operation. I'm just going to have a print with 2 new lines so that we can separate the input from the output. So radius is 10, 200. Let's say green this time. And we have separated the output. So the output is down here. It's easier to see. Radius is 10, area is 200, color is green, the ball is inflated. Let's now determine that the ball is not inflated. So we go to the initialization command, and this time we type false. Once again, note, it has to be a capital F. And let's now re-execute. So that's 10, that's 200, that's purple. And note now, it says 10, 200, purple for the color. And the important point here is that it now says the ball is not inflated. And the ball is not inflated because we have ensured that the has air property has been initialized to false. So this gives you the basics of creating a class, using that class to create an object, and also how we can add a bit of interactivity to the main program in terms of using the input command. So we are using our IO statements to accept data into the program. My suggestion is to actually take some time, go back through this program, type it up, as you see that I'm doing. Make sure that you're typing it up for yourself. And then we have some classes over here that we would have fleshed out even more. So I would encourage you, here is a class that we have fleshed out in C++. Take your time and reproduce the same class over in Python. And by doing that, you will increase your competence in terms of handling classes in Python. And the concepts will become even more clear. So that's where we end for this session. Take care.